All right, so we're going to look at scientific notation today. We're going to look at how that we can use scientific notation to take a large number and shorten how we write it. So that's basically what scientific notation is. It takes a large number and writes it in a shorter form. Now, that shorter form uses that exponents. Shorter form, okay? We'll use exponents just like we talked about the other day when we were looking at our number system and how we can take our number system and rewrite it as exponents. So it uses that system to work there. So like we talked that 1,000 is equal to 10 to the third. That allows us to take these place values and shorten them to do the work. So you can see there are a couple of examples. You have scientific notation for very large numbers greater than 1, but also very, very small numbers less than 1. Okay? There's not a scientific notation for less than 0. So this has to be a number larger than 1, larger than 0. So if we take this first one, the minimum distance from the Earth to Mars is 284,000 miles. So to do scientific notation, we find the non-zero numbers. So in this case, it's 284 are the non-zero numbers. And we're going to take that and write that in a way where it is between 1 and 10. Where can I put a decimal point to make 284 between 1 and 10?
2.84.
So it would turn into 2.84. So our goal is to make it between 1 and 10. Can't be greater than 10, can't be less than 1. So now, if that's my new decimal point right here, how far did I move it from the original spot?
5.
So I moved it 5 places. So that's what I'm going to say. 2.84 times 10 to the 5th power is the scientific notation for 284,000 miles. We typically use larger numbers when we write this. But now the Indonesian earthquake, let's take a look at one that's less than 1. So now we've got this same idea. I've got a number here. I've got my meaning carrying digits, or my digits that are non-zero, are 2, 6, and 8. So just like before, I'm going to rewrite that so that it's between 1 and 10. So my decimal point's now going to be between the 2 and the 6. So it's going to be 2.68. Now, I've got to count how far did I move my decimal place. So I'm going to go, okay, I moved it 1, 2, 3, 4, 5, 6 places.
Negative 6.
But I moved it
Negative.
in a negative way. I moved it less than 1. So it's negative 6 because I moved it to the right versus to the left. Okay? So now that we've kind of seen that, I'm going to give you guys a minute to go ahead and practice that process. You can pause the video now and practice. All right, now that you've practiced, let's really quickly go over the answers. This first one is going to be 7.5 times 10 to the 7th power. We're just going to do the evens on these, or the odds today. So we've got this one here. Let's take a look at the next one. 9.07 times 10 to the 5th power. And finally our last one, less than 1, 4 times 10 to the negative 2 power. Now let's go ahead and go the other direction. Let's convert from scientific notation back to standard form. So we look down here. We're going to take a look at this first one. We're going to go the same way. I've already got my numbers. Now I want to move my decimal point 2 to the right because it's a positive 2. 1, 2. So now the standard form of this number is 254. Let's take a look at number 8. I'm going to move my decimal point, but this time I'm moving it 5 times. So I don't really have room over here to do it. So I wrote, there's where it would have been. So now I'm going to add how many zeros. Now there's one place here. How many do I have left?
4 zeros.
I'm going to add 4 zeros to fill in the space. So my known number, instead of it being 9.1 times 10 to the 5th, is 910,000. Our next one, actually let's do a couple with negative. Let's try 10 and 11 with negative. So 6.7 times 10 to the negative 2. Instead of moving it to the right, I'm going to move my decimal point, since it's negative, to the left. So instead of it being 6.7 times 10 to the negative 2, it's 0.067. And we take a look at number 11. We can take a look at that same idea. This time I'm moving it 4 places to the left. So 1, 2, 3, 4. So I've got, how many zeros do I need to fill in these gaps?
3.
I need 3 zeros to fill in those gaps. Take a second and complete 9 and 12. All right, let us put those answers up there for you. 1,140, and finally 38 hundredths. All right, now how do we use that when it comes to exponent rules? That's what's next. How can I combine scientific notation? How can I add or subtract scientific notation? How can I multiply and divide with scientific notation? Well, it goes back to your exponent rules. For adding and subtracting exponent rules, you treat it like combining like terms. Okay? So because it's combining like terms, what has to be the exact same? The exponents, the 10 to the second power, 10 to the first power, have to be exactly the same. Okay? So the idea of when you come into scientific notation, this part has to be exactly the same, or you cannot add them. Okay? Or you can make them that way, and we'll talk about that next. Okay? So let's take a look at number 1. Number 1, I have 2 of the exact same pairs. I've got 10 to the second on both problems. Now that I have 10 to the second, all I need to do is add or subtract the 2 numbers in the front. So it's 5.2 plus 3.4.
8.6.
8.6 times 10 to the second. Oh, now here's the problem over here. Number 2, they're not the same, but I can make them the same.
No.
I can make them the same by moving my decimal point a little bit. Okay? I find it easiest to make the larger one less. So this one right here, I can make it 10 to the 6th. Where would I have to move the decimal point to make it 10 to the 6th? I'd move it to the right. So this would be 95 times 10 to the 6th and 1.1 times 10 to the 6th. Can I add them now?
Yeah.
I can, because these are exactly the same. So 95 plus 1.1 is 96.6.1, sorry, I almost said it wrong, times 10 to the 6th, but that's wrong.
You simplify.
I've got to go ahead and put that decimal back in scientific notation. So it means I have to move my decimal point one more this way. So my final answer is going to be 9.61 times 10 to the 7th power, because I added 1 going this direction.
Okay.
So now that we've had a chance to look at those, it works the same way in all the others. Okay? It works the same way with all the others. Let's take a look at 3 and 4, and then I'll let you guys practice some on your own. These 2 are not the same. So now I have to make them the same. I prefer to make this one. You could do either one. I prefer to make that one times 10 to the negative 4. So how I would rewrite this by saying, okay, well, I want to move it one more to the left this way. Because to make it 10 to the 4th, I've got to move it this direction. So now it's 318.318 times 10 to the 4th, and 7.24 times 10 to the negative 4th. Now I can add my 2 numbers, and I get 7.558 times 10 to the negative 4th, because this number is between 1 and 10. All right, let's take a look at the next one. Again, they're not the same. Let's change this one. Okay? Well, you know what? Actually, let's try something different. You want me to try something different and show you the other way?
No.
I'm going to keep it the same, because they've said no. So I need to rewrite this one. I need a 10 to the negative 2, so I can keep them exactly the same. Well, it means I've got to move my decimal point 1 closer to the 0. I'm going to move it over here. So now it's 0.68 times 10 to the negative 2. Now I can add these 2 together. I have to remember to line my decimal points up. So I have 8, 5, 3. When I added all my numbers together, it's 358. No, that's not right. 338. Helps if you add correctly. So it's 338 times 10 to the negative 2 power. Now that we've got those, okay, we kind of get the idea.
Why would you move that decimal over?
Because it's in the 10 range.
And she said exactly right. It's between 10. It's 3.38. That's between 1 and 10.
Okay.
All right, now pause the video and try the next few problems. All right, now let's take a look at multiplying and dividing. This is a little different. The best part about this one is you don't have to have like terms to combine these. You don't have to have the exact same exponents. You're going to either use the product or the quotient rule to adjust it. Okay? So if we take a look at this one, we're going to multiply or divide, depending on what you're told to do, the two pieces. So you're going to multiply and divide 2.8 times 1.9. I'm going to get out my calculator to do that. I get that. I get 5.32. Because with multiplication, I don't have to make it the same. It makes it even better. So now I'm going to follow my product rule. Well, 10 is my base, and 10 is my base, so they're the same. So now I have times 10. Well, the product rule says I would take 7 plus 4. So now it's 10 to the 11th power. 5.32 times 10 to the 11th power. If it's dividing, I would use my quotient rule. I would have subtracted. We'll do a couple division in a second. Let's take a look at this next one, number 3. Okay? So now I've got the same idea, still multiplication. So I'm going to do 8.4 or 8.5 times 3.4.
28.9.
So I got 28.9. Now I'm going to use my quotient. I'm going to use my product rule. -2 plus 6. So I get times 10 to the 4th. But this isn't right yet.
Because it's not between.
Because it's not between 1 and 10. So I need to move my decimal point one more to the right. So I'm going to add 1 to my scientific notation to give it 2.89 times 10 to the 5th power. Let's go ahead and take a look at a couple division before we go any further. So I've got division in 7 through 11. Let's take a look at those. So the same rule applies. I'm going to take that 3.72 and divide it by 1.2. So if I did that on my calculator, I get 3.1. Maybe I did that wrong. Make sure I'm right.
You're right.
I get 3.1. Well, great news, I don't have to worry about adjusting that number. Now I'm going to use my quotient rule. 8, the quotient rule says I subtract 8 minus 5. So 8 minus 5 is 10 to the positive 3 power. There's my answer. Let's take a look at number 9. This time I'm dividing 4.5 divided by 1.8, and I get 2.5. Now I'm going to follow my quotient rule. 3 minus a -7. Well, 3 minus -7 is actually positive 10. So this becomes times 10 to the 10. And we'll do a final number. Okay? 2.7 divided by 2.4. I got 1.125. And follow my quotient rule. -5 minus a -6.
1.
So I get times 10 to the 1st power. And I get my final answers. I get the process through. Now I'd like you to take a minute and try those. You can check your answers on the topic page. There are the completed notes for you to check your answers once you've had a chance to do it. When you're finished, your homework is posted online. If you have any questions, come see me in the morning.
Do you have to write the 1?